All right, sixth graders, we are going to start by reviewing the rules of divisibility. So I've grouped them into three categories depending on how you decide if a number is divisible by certain values. So the first set here is based on the unit digit. So it's divisible by 2, meaning you can divide by 2 and get a whole number answer if and only if the unit digit, or the digit it ends with, is 0, 2, 4, 6, or 8. So basically you have an even number. A number is divisible by 5 if the unit digit, or the number, ends with 0 or 5. And then for divisible by 10, it's if and only if the unit digit ends in 0. So some examples here: a number that would be divisible by 2, I can divide it and get a whole number answer. It would be something like 3,576 because the unit digit is even. It's one of these 5 numbers. That number is not divisible by 5 because it ends in 6 and it has to end in 0 or 5. So a number divisible by 5 might be 23,640 because it ends in 0 or 5. And divisible by 10, this number is divisible by 5. It's actually also divisible by 10 because it ends in 0, and it's also divisible by 2 because it ends in an even digit. Then we have 4, kind of has its own set of rules. Divisible by 4 if and only if the last 2 digits are divisible by 4. So I can have this huge string of number 141,237,536. This number I know is divisible by 4 because it's all dependent on the last 2 digits. 36 is a multiple of 4. I can divide 36 by 4 and get a nice, neat whole number answer. If that had been, say, 141,237,537, 37, the last 2 digits, is not a multiple of 4, so that number is not divisible by 4, meaning I won't get a whole number answer. I can divide it by 4, but I'll have a decimal. This number is divisible by 4. I'll get a nice, neat whole number answer. And then the last set is divisible by 3 and divisible by 9. It's based on adding all the digits together. So if the sum of the digits is a multiple of 3, I can divide, it's divisible by 3. And if the sum of the digits is divisible by 9, the sum of the then the number is divisible by 9. So thinking up an example takes a little bit more thinking, but let's see, 753. Is this divisible by 3? So to figure that out, I have to take 7, 5, and 3, take the 3 digits that make this number and add them up. So I get 7 plus 5, that's 12. 12 plus 3 is 15. 15 is a multiple of 3. I can take 15, divide by 3, I get a nice, neat whole number. So this number is divisible by 3. Now, is this number also divisible by 9? Well, 9 is the sum of the digits is divisible by 9, meaning it's a multiple of 9. 15, when I add the digits, 15 is not a multiple of 9. So this number, while it's divisible by 3, it's not divisible by 9. So let's try another one for 9. Let's see, if I take 1,200, so right now I'm at 3. I'm trying to get it divisible by 9. So if I add 5, 5, 6, 7, 8, I need one more to make that 9, right? If I add 1 plus 2 plus 5 plus 1, that is 3 plus 6, which equals 9, and 9 is divisible by 9. So this number is divisible by 9. Now, is this number also divisible by 3? Well, 9 is a multiple of 3, and it's a multiple of 9, so this number is actually also divisible by 3. And that is your divisibility rules.